Hello and welcome everyone to another webinar and demo. My name is Rich Martin, Senior Technical Marketing Engineer at Itential. And today we're going to be talking and really doing a little bit of a double click, a deep dive into automating data transformations for NetOps teams. And so what we want to cover, and my goal of this demonstration, is to really focus on the network practitioner and helping them to understand what we would call a data transformation and make it relatable to them, because I would argue, coming from a networking background myself, network practitioners are already experts in a very specific form of data transformation, and I'm going to use that as an example to help you understand when we're talking about data transformations, what that means in our platform, and for you to also recognize how critical and important, and it's really a foundational element in how you do your job today, when you're doing manual CLI configurations on network devices, but also in the world of automation, and specifically in the world of Itential's automation platform, how foundational it is and how much of this goes on, and then some of the features that we'll show you that make this part of it very easy and even reusable once you've already created your transformations. And with that, we're going to take a tour around understanding JSON schema, JSON objects. This is not a super deep dive in this. If you're interested, certainly there's lots of information out there, but I want to, at least from a network practitioner's perspective, to understand the basic concepts so that they can start using that in our platform, because our platform is structured around JSON. In addition to that, we'll talk about understanding API and CLI, and showing you the transition from using CLI and the similarities to then in a transformation to then doing something in an API. Like I said, we'll look at JSON schema, and one of the key components to this that I probably will drill in over and over and over again is data in, transformation, data out. Data in, transformation, data out, and we'll unpack that in a moment. We will actually build and test these data transformations and then implement them into a workflow. And on the right-hand side, it's just a concept of what we'll be doing today. We're going to be working in the Itential platform, specifically spending lots of time in data transformation. And we will be interacting with a workflow to make a change on a Cisco iOS device. And we're going to be getting, as a source of data, we're going to be getting data from a form, an input form from a user. However, if you've watched any of our previous demonstrations, and even in upcoming demonstrations, you'll know that we support a federated or a distributed source of truth, where data can come from many sources. And that's really even today, if you're doing manual network engineering and configuration changes, you already understand that a lot of your data doesn't come from one place. It comes from multiple sources of truth. But since we're deep diving today and trying to help my network brothers and sisters out there to understand how to automate in our platform, we're going to keep it simple. And we're just going to get all of our data in one nice place from a form input. And so for the demonstration, this is just a high level, and I'm actually going to break this down to make it a little bit simpler to digest into two workflows, but they could certainly be combined into one. But I think what we want to do first is we want to define that user data. So that's kind of our source of data, our source of truth. We're going to define that user data. The concept here is simple. Let's automate a change to an interface, or create a new interface, right? So we're going to provision a new interface on a Cisco device. But the first steps we're going to take, because this is all around data transformation, is we are going to transform that data into CLI commands, because this is easy for every networking practitioner to understand. And then from that, you can make a change to the device, right? Because once you know the CLI commands, we do a lot of copying, pasting if we're doing things manually. So you can do that, and we'll make sure we stop and view all the changes and understand all the concepts and the underlying flow of what's going on. And then as we continue on to the second part, we'll build upon the first part. Use a lot of that same information, forms, things like that. We'll modify the workflow a little bit. We'll modify the transformation a little bit, so that now we can implement a new workflow that can transform data that is appropriate for a change using an API. So a change to a network device, not using CLI, but now using API. And then you can kind of compare and contrast the two. And hopefully through all of this, you'll be able to understand and digest not just the concepts, but how you quickly and easily you can do this in our platform. Okay, so let me share my screen. Okay. So, like I said, the first stop on our journey today is our source of data. So, remember what I said: data in, transformation, data out. So, we need data in. Okay. So, imagine this: you're a networking engineer. Somebody says, "Hey, I need you to create an interface on this router." Where does that data come from? You know implicitly the commands, like let's call it a Cisco iOS device. You implicitly know, subconsciously probably, know what commands need to be done, but you need some sort of data in order to actually do that. So some of that data is, well, which router, what interface, where my IP address, what's the Netmask, would be nice to have a port description. So all of that data can come from a number of places in reality, right? You might hit an IPAM for the IP address. Let me get the next IP address. There might be an inventory system, or it could be a separate system, could be ServiceNow. You might need to pull information from the network. And so those become lots of sources of truth where you can pull data from it. So before you even get started to make a change manually, you still need to gather all that data. So just because we're focusing very specifically on data transformations, we're going to make it simple. And all of our data, like I said, is going to come from one place, and that's a form. So what we're really talking about is a user form. So in our platform, we make it really easy to create a user form. This is a pop-up form so that somebody can fill out data with some fields. So we can create that now. We call it a JSON form, and I'm going to call this WT1 form just to make it simple. But create. Okay, so now part of the thing about our platform is there's several different canvases. Now we're in the JSON. We're creating a form, right? So this is a canvas for forms. So you'll see all the elements that we can drag and drop here on the right, and the form we're creating here is in the middle. So the first thing we want is we're going to make a net. We're going to create a new interface on a network device. So what is that network device? What is the host name for that device? We have all kinds of different elements here. My favorite for this is a drop down. So you can have a multi-select. This allows you to create and to define only specific systems or routers that a change can be made on or selected on. So we'll call this router. We'll make it required, and then we populate the dropdown. And this, we're going to statically do this. So we're going to define every one of these options, and we won't do a whole bunch, but we have several core devices here. I'll add one, two devices, three different devices. We'll do four to have a nice populated dropdown. Okay. So we save that. Now we've populated at least one field in our form, right? So we have all of these devices that can be dropped down and selected. So that takes care of our router. So in order, again, to make a change to a device, to make a new interface, I need the interface name. So that's a text input field. And this is kind of a free form field that somebody can fill out. And let's make sure we label it, because when we label things, I'm going to show you where this gets translated into a JSON object. And these labels are important, especially as we start to map variable and data across the transformation from one task to another. So we want to make sure it's descriptive and labeling, not only to make it easy to fill out the form, but also on the back end, as we're building this automation, it's easy to line everything up as we build transformations and workflows. So this is going to be the interface name. Certainly needs to be required, and we'll save that. That's pretty straightforward. Next is IP address. Let's do that one. IP address is the label. We have an IP address. Obviously, we need a Netmask. Okay. Okay, and then finally, let's do a description. Okay. So thank you for bearing with me. So the cool thing about this is we've built this on the canvas. We can take a look at what it's going to look like when it's actually run in an automation. So this is kind of a test that we're doing. And we can see, all right, here are 1, 2, 3, 4, 5 fields that we defined. Here's our drop box or drop down box. We can select one of several of these routers, and that's part of the inventory that's within the platform. We can select an interface name. Because we're testing, we'll do loopback. IP address 1, 2, 3, 4 is a test. Netmask. Oops. All right, and then a description. So we're simply testing this form out. Now, here's the great thing about this, because this is where we kind of do a double click into this. If I click on show form data, it's going to show me something. And what you're looking at is uh, technically it's a JSON object. It's got some information that helps define it as schema. And we're going to unpack that a little bit. But remember what I said, data in and data out. So this is going to be, this form, as we're building it, is in a workflow, is going to be a task. It's going to be a box, a step in a workflow, right? It's going to be, in fact, to be our first step in the workflow. The data in comes from the user, right? It's going to pop up the form. We're going to fill it out, or potentially some other user is going to fill it out with the required information so that we know the specific details so that we can create this interface. Now, what this is saying is the data out is going to be in this format. It's going to have a field called router. And this is actually, since this is a JSON object, one of the things to understand is this is called a key. And then it's separated by a colon, and it's going to have what it's defined as, right? So it's easy to understand from a network perspective. What's the router name? Core ATL 0, right? What's the interface name? Loopback 301, on and on. We're defining these as strings. That's another data type. So there are several data types: objects, strings, numbers, arrays, booleans. We'll hit on several of those in this demonstration, but the key concept here is this is what the form, when it's running in a workflow, this form is going to output this data, and it's going to output it in this format. And we've defined this. So the data itself is represented as a JSON object, is going to follow this format. And that format is defined by a schema, which gets created when we create this form. That's all kind of done on the back end. So when we talk about JSON, it is a standardized format, JavaScript object notation. Again, we're going to unpack that a little bit. We'll talk a little bit why this is a really beneficial thing when you're doing a lot of data manipulation, and that's a big part of automation. But it is also at the heart, and it's central to our platform. We represent information. We defined JSON schemas, and if we get data like from a form or from a call, an API call into a system or a network device or the cloud or wherever, we represent that response data, that data going out as JSON, right? It's put into that format intentionally because it has a lot of benefits, especially when we're talking about doing automation, right? So that's the key concept here. So when this form gets run, this is the data that comes out. Now I'm going to copy it, and I'll show you why I'm going to copy it for a reason. So we finish our form. So that's our data in. Remember, data in, transform, data out. So the next step we're going to go to is we're going to create this transformation. So I'm going to duplicate this so that we have another view here into the platform. And so I'm going to create a new transformation, and we will name this WT1. Since the first part of this is going to be around defining CLI, that's what I'm going to name it. And now we've got another different canvas, right? This is the canvas for building these transformations. And technically, you're going to see, we call this in the platform JST. That's JSON Schema Transformation. And the whole idea when we talk about schemas is, which we'll get into in a minute, is data in, data out. And a schema is a definition of what that data needs to look like coming in or going out. And remember, if you think of a workflow as steps one after another, in its simplest form, the data from a previous step, the output of that, the data output of that step can be used and probably will be used in subsequent steps after that. And that's what the transformation's about. So think of it this way: if somebody hands you a piece of paper with an IP, with a host name of a router, an interface, an IP address, a netmask, and a port description, kind of like our form, you would still, as a network engineer, have to do some transformation to turn it into the proper CLI commands. And you do this, and this is why this is the area that I think network engineers are absolutely professionals in. You can give them any amount of network data, like the things that I just mentioned and things we defined in the forum, and they can instinctively in their mind come up with the CLI commands to implement those changes on a particular device, right? Cisco, Juniper, Arista, whatever. And so I want to replicate that process here to help you understand how that can and should be automated. And then we'll go from there. That's the launching point to go from there. So our incoming schema. So this data transformation needs to take data from somewhere. It's going to take it from our form. That's our kind of our source of data, our source of truth to this. So we have to define this incoming schema. And so in order to do that, we can do it manually, or recall what I just did when we previewed this, right? I clicked we did the show form data. Well, I still have it in there. There we go. Still have it there. We did the show form data, and then I clicked copy. So remember, data in and data out. So one of the little shortcuts we've done here is we can infer a schema from the data out. So that form sent is in our example is sending this data out, right? So that's what I copied from that preview form. This now is going to become the input. This format, this JSON format, is going to be the input for this transformation. That's why we're defining it as the incoming schema. So the schema is going to look at this actual object and determine the correct format it's representing, right? And so we can do that. So we don't have to build it by hand, especially for complicated JSON responses and JSON objects. And a lot of them can be very complicated, especially like if you're looking at ServiceNow, where they have lots of variables and fields and things like that to return. So an easy way to do it is to capture that data in the JSON example, and then click this button here. And now it's inferred everything for the schema. So the schema is the definition of what we expect the data to look like as it's coming into the transformation, and it absolutely must match this. Otherwise, that data is not considered to be usable and the transformation won't run. And so it infers it from this. So it understands that there are properties to this particular object. The object has a property called router that was inferred from here. It's a type string because of the way it's defined here. Again, it's a little bit deeper into JSON, but strings are encapsulated in double quotes. That's probably an easy one to understand. And so it's inferred that, and it's also captured as an example the actual data from that JSON example from our form. And it's done that for every one of these fields. And so now it's created that definition. So that's what the schema is. It's a definition of what the data needs to look like. And this is very handy, especially not only just the inference to create the schema, but the fact that it's storing this data as examples that we got from the output of our form. So the only thing it really is asking me here now is to define a unique ID, just basically a unique name. So we'll call this user data from form. Deleted. There we go. Should be able to save that. Now you'll notice it populated, since we defined that schema, it populated a new object, and that object has these 5 elements, right? And again, this was inferred from our form. So that basically guarantees that the output from our form here is going to match the schema we've defined that's going to become the input for this transformation. Okay? So that allows us to get the data in. So we need to get the data out, and in the middle of getting the data out, we need to transform it. So the next question is usually around like, okay, what's the output schema, the outgoing schema need to look like? Now, usually it has to match an API call further down in the workflow, and in our second workflow, we'll cover that. But for right now, just to aid my network colleagues, where our outgoing schema is going to be very simple. It's going to be a string, and it's going to be, let's format this data into a set of Cisco CLI configuration commands. That's really all we want to do for this step, as an example. So we have to give it a unique ID. So we'll call it Cisco iOS CLI commands. And this type is, we're just going to define it as a string. We just want the text information. Okay, so that's our output schema. Now, we're going to be able to map data through, but in this case, we need to really transform data in some way. Drop that here. Okay, so we've got all of these methods on the right, and these are additional methods that we can drop into the canvas in order to manipulate data. And there's a lot, I get it. Especially if you don't have a background in programming. If you have a background in writing code or doing some programming, some of this is going to look, pretty relatable. But if you don't worry. As a network engineer, there are a few of these methods that you really need to focus on. And one of them, one of the big ones, is located under string, and it's template literal. This allows you to kind of reformat data in a string in a way that's uh, to transform data using a template that you create in this particular method, so that it can be used. You can kind of manipulate and create a template and substitute variables so that it can be used as a correct format for something else down the line. This is a very, very handy one to know, especially right off the gate. And I know that's a little confusing, but let's break it down because I think I can make it really easy to understand. So if I click this button, there's not a whole lot going on here, but if I click this button, this allows me to create a template within here. Now, let's forget about the template piece for a minute. Let's focus on literal. What I'll ask you is what would if you were going to, given that data on the left, that's their data in, what would be the literal CLI commands that you would type in config mode on a Cisco iOS device in order to create an interface? And that would be an easy one, right? You'd say interface, loop back, what's called 301. And then I would do IP address 1.1.101, let's say, with a netmask 255.255.255.255. And then we could go description test. And you would be right. That's literally what you would type in. Now let's turn it into a template. We know that the data coming in from on the data in coming from that form that matches that schema is going to change based off of what's in that form. So obviously, static or hard coding this is not desirable. That's not what we want. What we want to do is create variables for this and then map that data into those variables. And to do that is really simple. You just have to remember this format right here. So string and then open curly brace, and then give it a name of the variable. And I like to keep these pretty as similar as possible. So this could be interface name, because this should be a variable that holds that interface. In this case here, we're going to create a variable called IP address. Of course, another one here for netmask. And finally, for the text field description. So as long as I'm following this format of the $sign and then within the curly braces, defining a variable, when I click this update, it's going to, this method is going to understand the variables I defined and now make them available to me. So now we've created our template. We literally put the iOS commands we would type, and now it's created a template so that we can map the variables from our data into the correct spots here. And this is why using the same names becomes so nice, because it's very easy to map these together. So now my data incoming from the form is going to be in this format, and because it's JSON, it's very easy to query. It's very easy to pull data out, and in this case, use it to manipulate it and put it into a different format that's applicable for our outgoing schema. So now IP address, we can just simply map these fields over. And notice when I click one of these, if something is already, if we can't connect to it, it's red, it's in the red. But if it's possible to connect to it, it's in the open or blue. You'll also notice here, because this is part of the schema, this description is string. That's part of what we've defined. That has to be a string. So coming out, this is string data. But you'll notice here in the template literal, it accepts a lot of different types, because it's going to convert any of those types as part of this method into a string, because it's going to output everything as a string. So it's really very open, and some tasks or some methods are, very specific. We'll see in a moment. Some of them allow this to be open. It just depends on the function and the work that it's doing. So we'll map that to description. And now I can say, okay, here's the output of that. So after this data, these variables are applied to this template that we created, that is the literal CLI commands. I can map it to my outgoing schema. And so the outgoing schema, whatever we define here, is what is going to be the data out from this task, which can then become the data in for another task, so somewhere down the workflow. Okay, so the cool thing here is we can save this and we can test it. We're not running this live in a workflow, but we're testing it to ensure that this transformation does what we want it to do. So when we created that inference on the incoming schema, it remembered all of that example data, and now that becomes our test data here. And we can change this, and we'll change it in a moment as test data, but it's really, really convenient that it does all that. So if I click that, it's going to say, okay, here is the output, right, from our outgoing schema, and it's going to output that text. And you'll notice that is the literal text we put in, and then the template that we created. So we based off of the input, that test input from the user form, that got mapped into variables, which got substituted in your literal template to fill in the fields for the interface, for the IP address, the netmask, and the description. Congratulations, first transformation complete. And this is something you can understand, right? Because as a networking practitioner, you do this every single day. Now, that data may come from all kinds of different sources that can be automated in our platform. I think we've shown that. We will continue to show that. But to show how these JSON objects function, how to map things around, why we use them, and specifically how we can map them to an outgoing schema. In this case, the schema is a Cisco, is a proper set of Cisco iOS commands. And so think about, if you're a networking practitioner, as an output schema, you already understand this, because if you type something wrong in the syntax of like a Cisco iOS device, it tells you, no, thank you. I can't do that command. You had the wrong invalid entry, wrong command. There was something wrong with the syntax, right? Saying you can't use a set of Juniper, Juno CLI commands in a Cisco, right? The syntax is wrong. So what that's basically the analogy is, you already are familiar with the concept of an outgoing schema. It's the CLI commands that you have to manually transform this data on the left into the CLI commands on the right. And so what we've just done is probably something you do every single day. We've just automated it in a couple of easy steps into transformation. And that's really the heart of the transformation. Now, obviously, this is a simple example. We did Cisco. Let's do Juniper. So let's do that one next. So we have to define another outgoing schema, but this is simple. This is going to be Junos CLI commands. Again, another string. All right, so that's our outgoing schema. So now when we're done with this, we should have two different outputs, because we have two different outgoing schemas. And by the way, for incoming schema, although it's a bit more advanced, we can create more incoming schemas and map data from different data sources as well into a single transformation. We won't do that today, but that's something upcoming we will talk about in a different one, different webinar. Okay, so let's focus on this. So it was easy to do, use that template literal. So that's our first step, right? Let's use the template literal. And we should be able to do the exact same thing, except we have to put it in Junos CLI, right? So Junos CLI is a little bit different. Set. So if I'm in config mode, I could do a set interface. Then we're going to have the interface name. So I'm going to go ahead and variabilize everything, since we've already gone through that step before. And then, unit 0, family, iNet probably is getting us at the lowest, the physical layer there. And then we can set an address. And then we need the variable for IP address. And then a slash. And then, of course, it requires a netmask as well. Okay. And then next line, we need to set the description. So it's going to basically be the same in a sense, because we still have to do this. Interface name, unit 0, iNet, description. And then we need to use the variable that comes from our form for description. Okay. Now that should be it. So we click update and we get those variables defined. Now we should just be able to map, right? Interface name to interface name, IP address to IP address, netmask to netmask, description to here, and then our output should be a string, and we can test it and take a look at it. Okay, so you'll notice here that our output, so the Cisco CLI output hasn't changed. And by the way, these are new line characters. It shows everything on single lines. We'll see a kind of a prettier output when we get to the workflow. But okay, let's take a look at our Junos command. So set interface. Okay, loop back 301 may not be the exact correct interface, but bear with me just because it's an example. If our form data was different, we could have, xe-2/1/0 or whatever it needs to be. But you get the point. That comes from the form. Unit 0, family INET address, 1234, right? It's matching what the Cisco was because we're using the same data sources, the Netmask, and then, yeah, the description test. So that looks good, right? Well, no, not quite. So I know there's a few Junos experts in the audience. You know the problem here. While Cisco uses the lovely dotted decimal notation for netmasks, in the world of Juniper, they use the prefix, right? The prefix length. So that mapping wouldn't work. Now, how do you solve that problem? Well, in our automation platform, there's several ways. We could solve that problem by creating a new form that's specific to Junos instead of expressing netmasks as the dotted quad notation or dotted decimal notation. We could express it as CIDR prefix length. That's one way to do it. That would be a way to do it within the form. Can we do it within the transformation? And the answer is yes. And there's actually a couple of ways. And so let me show you one. So let's think this through. Clearly, this is not, we have to do some transformation before we get to Netmask for this Juniper, right? It has to be changed from dotted decimal to prefix length. So how could we do that using some of the tools on the side? So the first thing I could do is I could say, well, if the netmasks equals 255, 255, 255, 255, so there is an equality method here, then I could tell it that it needs to be /32. So if I map this over to here, this equality allows me to compare two parameters, right? In this case, the string that we've been passed to from the form called netmask, and we could say 255, 255, 255, 255. So we're going to compare those two, and then it's going to, and if they're equal, it's going to return a Boolean, which is a true or false value. So that's the data type. And if they're equal, it's going to return a true. And by the way, anytime you have one of these methods, you can click here, or you can hover here and get information on how it works. And if you click, you'll get into some deeper documentation. But this one's pretty simple. Okay, compares two things, either gives me a true or a false. True if they are equal, false if they're not. So then what do I do next? I need to have a conditional, and we can use the ternary conditional here. So what the ternary conditional does is it says if something is true, then we're going to output a certain value, and that value can be one of many data types. But if it's false, we're going to output a different value. Okay, that might work for us. So you see how these data types are the same, Boolean to Boolean. So they already match, so that's going to let us do that. So this should pass true if it's equal to 255, 255. And so therefore, we can statically say then output from this the number 32 or a string 32. But we actually have to fill this out too as part of a requirement for this method. So we could put 24 in there, and let's test this out and see what happens. So now I can map that into the template. So we've done a little bit more data manipulation on the netmask to try to get it into the right format for the Juniper CLI. Let's see what that does. So let's save it. Let's run it. So again, here's my data input. I'm going to leave it the same for now. So 255, 255, 255, 255. This should return a /32, which is the correct prefix length. And sure enough, there it is. That's awesome. Let's run it again. What happens if we do 252, right? Which should be a /30. There's a problem because there's only one other path that this can take because it's false. So it came in here, compared it to 255. So we redefined the data set, the example set, to 252 on this last quad here. That was not equal to that. So it returned a false. Therefore, it didn't take this. But see, this would only work if it was 255, 255, 2550. That's the /24. So even though we could do it and it would work for one case, if this was a /32 NetMask, it's not going to work for all cases. So maybe that's not the best solution. So, but it shows you some of the techniques we can use here. So what is a better solution? I'll show you. Recall how I said earlier that we represent everything as JSON objects defined by JSON schemas. JSON schema defines what an object should look like, and the object actually carries the data, right? And it must match the schema, and that's the whole concept of data in, data out. Incoming schema, outgoing schemas. Data coming in has to match those schemas to be considered valid, and going out, same thing, because outgoing data on any automation task can and probably will be used for another task later in that workflow. So all of this is central to what we do. But why JSON? Because it has a lot of advantages. One of the advantages is it's structured data that allows us to query a JSON object, even a very large JSON object, and get right directly to the data we want. So here's the analogy. You're on a Cisco iOS device. You're looking for a very specific piece of data in the configuration. So you do a show config. Unfortunately, the configuration file is something like 2,000 lines long, right? And where is that data? Now, normally, of course, because you can't sift through all that data, and you've done this out of your own experience, you've done this so many times, you can probably pipe it through some sort of include to query out the information specifically you need, right? So that's what we normally do. But if you didn't have that technique, going through all of that data would be time consuming, monotonous, and you would think, wow, I wish there was a way I could go straight to the data I need. If there was a marker or a tag or something, and just get the data I need. And that's one of the big advantages of JSON objects defined by JSON schemas, is because we can do that now. We can query exactly what we want out of a JSON object. So that's what we're going to do. We're going to use a JSON object to solve our little Netmask mapping issue. So if I go to new object from this method, and I'm going to create a new object. And that new object is going to be something unique. I've already created it here, and you can see it in my browser. If you're a network engineer, this maybe is all too familiar. The format it's in is in a JSON object, right? But the data you should be familiar with. And this is just a simple lookup chart for dotted decimal netmask to prefix length, right? I'm sure every network engineer out there has this burned into their brain. They never have to look ever, ever, ever. But for our example here, I'm just going to, we could have done all of them for, but we're just going to do a class C subnetting table, but it's what it is. It's a table. And so the key value, so we're going to be able to search this, query this JSON object, because this first value here is a key, and because they're all unique, we're going to be able to query based off of the dotted decimal notation, and the value that it's assigned to is going to be the prefix. So we've created a cute little map here that's going to give us the information we need based off of that dotted decimal notation that we get from the form. Again, this is just as an example showing you how powerful these transformations are. So I'm going to copy this, because what we're going to do now is go back into our designer, and we're creating a new object. This is a JSON object. And if I paste that in there, and I know it's all in one line, that's why I wanted to show it to you first. If we paste all in here, that will now create that object. Okay. So now that we've created that object, we need to be able to query it. And so if I go here, we can go to query. And this allows us to query this object, and it's going to say, hey, what's the object you want to query? That's the one we've just created. We're going to do a pass on null to be true. And then we are going to say, okay, what's the string we're querying for? Now, normally I could just map this into here like this. But there's a little nuance here. As an identifier in JavaScript, JSON objects should always start, I won't say should always start, but should not start with a number. So normal query, we have to use kind of a unique form of query called a bracket query. But normally I could just map Netmask into there, but because my JSON object here starts with a number, we have to do one more step, and a template literal helps us with that. It in the right format to query. All right, so the bracket notes. So normally we could just do this. I could variabilize the Netmask like this. But we have to put it in what's called bracket notation. So it has to look like this in order for it to do the query correctly, because our object, JSON object, has key value fields that start with a number. Usually it has to start with a letter or certain special characters. So we'll do it that way. Now we can map that. But again, it's another step of data manipulation that I'm showing here. And now we can bring that into here. So now our query parameters are defined by this template literal, which comes from Netmask. And then we're going to query this object. And now this should bring us to our Netmask for the Juniper CLI. Save it. Let's take a run. Can leave everything there. And we did a 252 as the Netmask, so that correctly came back as a /30. Let's test it one more time. 255, so that should come back as a 32. And there you go. It came back as a 32. So this is how you manipulate data, right? And again, these are things network engineers do every single day. But I wanted to show you that this process they're already familiar with, how you can now automate it and map it in these transformations, and how you can use these steps and techniques to automate the data manipulation. And by the way, you save this like we just did, and it can be used in one workflow, but not just one workflow, many workflows. So, and it's reusable. So let me go into, let's create a new workflow and start to use this just to see what it looks like. So we'll create a workflow. We'll give it a name, WT1 workflow CLI. Create it. And so really there's a couple of steps to this. We need to show our form. So data in. So here's another canvas. When we're creating a workflow, here's a canvas. Everything on the right are tasks or elements for either network devices or services, right? So we have onboarded here NSO, DNA center. It could be your SD-WAN controller, or IT systems, right? We have ServiceNow, could be sources of truth, like Netbox. All of this is available to the right for you guys, for everybody to start building workflows with. They become basically boxes or steps. We call them tasks in a workflow. So our first task is JSON form. So we need to show that form that we created. All right. And then our next step was going to be that transformation that we just created. And then we're just going to do a view of the CLI commands that we created. So we'll do two of those. Oops. One for Cisco and one for Junos. So now we can just now we can start leveraging all of these, the forms and the transformation that we had earlier. So now when I click into one of these tasks, it gives me a chance to fill out some of the data, right? So number one is this is going to be get data from user form. Data in, data out, remember? So it's going to ask me, well, what form are you referring to? So what is the name of the form we created? It was WT1 form. So that we input that here, form. And in this case, it says instance data. This is the incoming, by the way, this is like the incoming data. So it's asking us, where's all this data coming from? It's coming from the input form. And this instance data, if we click here, it just says it's an object that allows us to define default values in the JSON form. So we can create default values here, but it's a requirement. So it requires an object, and we can give it an empty object, right? An object in JSON is just this, to open and close curly braces. So that satisfies that task requirement. So that's going to show us our form. Now we're going to get to our transformation. So our JSON transformation is transform to CLI. Okay. What's the transformation we created? WT1 TFCLI. Okay. Incoming schema. That should sound familiar by now. Where is this user data coming from? Well, it's coming from our form. So what's the form's name? Get data from user form. That's what we want. And the value is the outgoing schema that this puts out, which is called export. So this is where I was talking about data in, data out, and then the next task is using the data out from the previous task. And it could be several tasks before. It doesn't have to be the very next task, but subsequent tasks can use data from previous tasks. So if we save that, now we've done our transformation. So view data is going to stop and just show us some amount of data. And we have to tell it where to get the data from. Again, incoming information. So we want to get the data from that transformation. And what do we want to get? Because this is going to be Cisco CLI. We want to get the Cisco iOS CLI commands. Again, this was defined in our transformation here when we set up the outgoing schema, Cisco iOS CLI commands. So that's what we're referencing here for this one. And for this last step, another view data, this is going to be Juno CLI commands. And again, we will reference a previous task, the same transformation, but instead of choosing the Cisco, we'll choose the Junos. Let's save it, and we can save it here, and we can test run it here and see what happens. So once that's run, if I click view job, now it's running, and we can actually view the instance of it running of that task. The first step was to ask us for input, if you recall. So this is the form we created. Core ATL0 is the router we're going to use. Back 301, 1.1.1.1, Netmask 255.255.255.255, and our description will be test 123. And when I click this, it's going to continue down that that workflow. The next step is our transformation. So I'm looking at this in a visual mode. It finished our transformation, and now it's sitting waiting for us to click on these. These blue tasks are manual tasks. They will stop the automation, and then we have to pick them up as a manual task. But the transformation occurred, right? And remember our incoming and outgoing schemas. We can look at the data now that this is run through this particular transformation, and we can see, aha, here's that data that was passed to us, right? We created the schema to define that on the incoming, and the outgoing, this is what it sent back out. Precisely just like when we tested it. And so finally, let's go to this manual tasks here. And now let's take a look at that blue task, and it's going to pop up. There's our Cisco CLI commands. And everything looks good there. So if I click success, it's going to go to the next step, which was the second view data, which should give us our Juniper CLI commands. And there they are. And yes, it converted our Netmask into the prefix length correctly. So that's the first step in helping you to understand these JSON transformations. Now you could literally take this automation, the output that we just saw, copy, paste, SSH into a device and paste it into there. But that's not where we want to stop, right? Our automation platform is not about making copy and paste very simple for you. We want to automate everything. So the actual network change needs to be automated itself. And that we're going to use an API. Okay. And while this may sound complicated, it really isn't. I've just stepped you through everything you really need to know in order to do this last step, which is to access an API to make a network change. Okay, so let's go back into Automation Studio here. And now let's create, we're going to reuse some of the work, but we're going to create a new workflow. And we're going to call this WT1WF API, because this is an API-driven one. Okay, and we can work quickly through a lot of this because we've already done a lot of it. So first step, data in comes from a JSON form. So I can search here, show JSON form. And we can reuse the same form that we had before, which is WT1 form. Our instance data, just like before, is empty because we're not going to set any defaults here. We are going to have another transformation. So we can bring a transformation in, right? And that becomes our second step. Data in from our form, that's our data source, data in into the transformation. We're going to transform it into something that now makes a network change. And recall when I said earlier, depending on what part of the network and you know what is controlling it. So, for instance, we can make a change to a network device, specific network device, which is what we're going to do here. But it's always going to be represented through an API call through some other mechanism. Because again, we're at the heart when you think API, we're defining schemas because we want to validate that the data is correct and we have the right data before we automate anything, right? Don't automate anything, especially network changes with data that's not valid. So that's why schemas are important on one side of it. The other thing is we normalize everything. So everything that you connect to in the network, whether it's physical, whether it's virtual, whether it's cloud. I mean, think about your network devices, SD-WAN devices that are accessed through a controller, something in the cloud that you're accessing through cloud APIs. That's all normalized on our canvas, so that even though all of those things are managed in different ways, we still create an API interface to those things if they don't already exist, so that when you're building automations, especially those that are making changes to the network, it's a very standardized way of doing it. And so you always get into this mentality of understanding these schemas, JSON, and the API requirements. So the other cool thing that we have is the ability to, I'm sure, especially if you work in a big enterprise or service provider environment, there's probably already scripts out there, Python, Ansible, whatever that people are using to do some sort of network automation. And so one of those things that we can do is we can onboard those scripts in a part of our platform called Automation Gateway, and we can attach an API and make it API accessible. And the way you do that is simply by defining a JSON schema for the input, just like we were doing in the JST designer when we're making our transformations. So that same technique can now take a working network script that you or your team are using, and that can be a drag and drop part into our canvas. That's exactly what's going on here. This is a Python script that basically is just custom built to create or even update a Cisco iOS interface. And that's what we're going to leverage here. So that's our third step. So we'll look at that in a second. That's basically it. Data source, transform data in, transform it, data out, and we're passing it along to via an API to a script, but it could be a controller, it could be a cloud API, whatever that device is to make the change. So we just now need to make sure this transformation takes that same data and manipulates in a way that's useful for this particular API call to make that network change. Okay, so let me save that because there's some things we can't quite fill out yet. And we're going to create a new JST here. We're going to call this WT1 TF API. Create. Yes, it's okay. Can leave that. All right. First things first, where's our incoming data coming from? The same form. So I can go back to here, copy it, paste this in, and infer. Just like we did earlier, I can infer, and then I just have to name this again, data from user form. All right, there's our data. Outgoing schema. What does that need to look like? Where do we get that information from? Let's go back to our workflow. Since this is the API call to a script, but it's still an API call, just like everything on here essentially becomes API calls when we talk to anything that's network related. If we double click it, it's going to tell us the incoming schema that it's expecting. So now this is where we are going to define, this is where we get the definition for our outgoing schema, because data out becomes data in, the data in here. So we have to satisfy the requirements here. So we can see that there's hosts, interface name, description, IP, netmask, and the types are array, string, 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 string. So we need to replicate that here. So the first thing we can do is we can go back into our designer, and we need to create hosts, right? Because that was the first one. And we're going to create this manually, and it was a type array, remember? Now, array is another data type. An array can be one or multiple items inside an array. It can have multiple items, and you can access them by their element number in the array, like what position they're in. But an array specifically in JSON is kind of bookmarked, not by curly braces, but by the regular regular brackets, straight brackets. So we have to convert that, and it says host. An array means implies that you can have many of them, right? Because you can have multiple elements in an array. So really what that implies is that this particular script, if you give it multiple elements in an array, could probably iterate over all of those elements to do the same kind of change. Now we're not going to do that here, but we can also pass it an array of one element, which is what we're going to do. And what that array is it's our router name, right? But we can't map it directly because it has to be turned into an array. So again, we have to do some data manipulation. So how do we do that? Well, we create a new array to satisfy the transformation from a string into an array of one element, the router name. And that will satisfy the outgoing schema, which now gets fed back into the incoming schema for this particular network change. And the rest of them are pretty straightforward. We have an interface name. They're all strings, description, IP, netmask. So we can create those very, very quickly. So IP address, string. Let's see, I know we had netmask, interface name, and description. So I can actually clone these, even though it's not saving me a whole lot of work. Every bit counts. Netmask, save. See, host, IP address, netmask, interface name, and description. Okay. Now here's the cool part. Remember where it was incumbent upon us in our earlier example when we created the CLI outgoing schema? It was incumbent upon us to put the right commands in to actually do a configuration. That all of that responsibility is now on the API call. All it really wants is the data. What is the data? So it's actually, and so you'll find this across many API enabled network controllers, things like that. You'll have API calls for like create interface or get interface details or update interface, things like that. They're very specific to the function you want to do. And really, it's just passing the data that's required to identify what interface and what you want to update or create. So now it's just a matter of mapping like we have before because it's a string to a string. So all of this should be really straightforward, just like that. So if I save it, we can always test it here. We can run it, and here we go. We see that the output of our transformation turned our string, which was core ATL0, now into a proper array to satisfy that API call to make the change, and the rest of them were mapped directly. So that was a lot simpler for doing this with API. So just because you're doing something in an API doesn't necessarily mean it's going to be more complex, but the functions and the methods are there to do all of the different data manipulation that's necessary. All right, so with that, let's go back to our workflow and let's start filling. Let's make sure we have everything filled out here. That's correct. Now that we've created our JST, we should be able to select it here. There it is, the API JST. Where is this data coming from on the, so our incoming data, our incoming schema, where is that data coming from? It's coming from our JSON form. So we select that. When that data gets manipulated, transformed, and the output, that's going to become the input for this. So now we're going to have to map, instead of statically assigning anything, we're just going to map from our transformation that we just created the variables that we've outputted as our outgoing. So they're all understood and known here because we're referencing it. So interface name is going to go here. I'm going to select that reference task. It's going to give us all the outgoing variables that are available that we've defined. So that's description, IP address, and finally netmask. So we save that. So now we should be able to run this and see that the whole process all together. Save it. We'll view the job as it's running. Of course, the first task is to ask us for the data. I'm going to make the change on this router. Loopback 301. I'm going to create the IP of 1.2.3.4, Netmask, and description. Okay, so if we go to visualize, we'll be able to see we finished the form. It went through the transformation. Now it's actually making the network change to that API call. So what was the incoming? The incoming was the data from the form that we filled out just a moment ago. The outgoing is now formatted in this way. And so that network change is complete through that API call. The incoming was the data we passed from our transformation. After we've done all the transformation, that became the input for here. And the output is from the API task that's making the network change is a success. And so one of the other things we can do in our platform is we can take a look at some of these devices in real time that we have onboarded. And so if I load the configuration for core ATL 0, which is what we just worked on, so we went data from form, transformed it into a format. It was very straightforward this time around. We actually did a more complex data transformation for the CLI, but we still did some transformation nonetheless to put it in the correct format that the API call, which is calling a script, can actually use. And so the result of that after it was done was it did update our interface loopback 301 with our right description of webinar and the IP address we specified. So there you go. I hope that was helpful to you. You may have to rewatch this webinar several times to get it to go, but I think all the data was there. Hopefully that was very relatable to everybody that's a network practitioner. And even if you're not, hopefully that's relatable in some way. And again, I just want to thank you very much for your time. And we look forward to hearing from you or you tuning into our next webinar. Thank you very much and have a great day.